When we talk about the history of astronomy, it's easy to think it just makes this giant leap from the ancient Greeks like Ptolemy straight to Renaissance guys like Copernicus, right? But what about that huge thousand-year gap in the middle? Well, it turns out that gap wasn't empty at all. It was filled with this incredible and honestly often overlooked chapter in science, the golden age of Islamic astronomy.
And really, it all starts right here with this idea. For the burgeoning Islamic civilization, looking up at the sky, well, it wasn't just some abstract hobby. No, it was a practical, even spiritual necessity. This verse from the Quran, it frames the stars as more than just pretty lights. They're a divine guidebook, a tool given to help you find your way, whether you're on land or at sea. So right from the beginning, the cosmos was seen as something to be used, something to be understood.
Okay, so how does that work in practice? How does faith actually push a need for, cutting-edge science? Well, the answers are all tied up in the day-to-day life of this massive, expanding civilization.
It really boiled down to three huge drivers. First up, the Qibla, the direction of Mecca. Every Muslim has to pray towards Mecca. Easy if you're nearby, right? But what if you're in Spain or Central Asia? Suddenly, you have a really tricky spherical geometry problem to solve. Second, prayer times. The 5 daily prayers are all linked to the sun's position. You absolutely need precise astronomical models just to know when dawn is or when the sun hits its highest point. And third, the calendar. The Islamic calendar is lunar, which means you've got to be able to predict exactly when that first sliver of the crescent moon will be visible to mark the start of a new month, especially for something as important as Ramadan. See, these aren't just philosophical musics. These were everyday problems that demanded a scientific solution. They literally fueled a revolution in astronomy.
Now, before they could start innovating, the scholars of the Islamic world did something incredible. They kicked off one of the biggest knowledge-gathering projects ever. They weren't interested in reinventing the wheel. Nope. Their plan was to find every wheel ever made, study it, and then figure out how to build a much, much better one. And the heart of this was in places like Baghdad's legendary House of Wisdom. It was just a flood of knowledge pouring in. You can see on this timeline, in the 770s, they're bringing in and translating Indian astronomical texts. This was huge because it gave them powerful new math, like the sine function. Then they absorbed centuries of Persian star charts and data. And then, the big one, around 827, they translate Ptolemy's Almagest, the absolute Bible of Greek astronomy. They were literally pulling in the best of the best from every direction. And listen, this is the key point. You have to understand, they weren't just librarians. There's this old, tired myth that they just kind of held on to Greek knowledge, keeping it safe until Europe was ready. That is completely wrong. The reality? They were intense critics. They were collaborators. They read this stuff, they took it out into the field, they tested it, they debated it fiercely, and they made it their mission to fix the mistakes they found in the ancient texts.
So all of this critical thinking, this testing and debating, it leads directly into the next phase. An era that wasn't just about old theories from books, but about rigorous, systematic, hands-on observation of the sky.
And this wasn't some hobby for a few rich guys. We're talking about state-sponsored big science. Rulers like Caliph al-Ma'mun poured money into this, setting up the first real major observatories in places like Baghdad and Damascus. Think of them like research institutions, staffed with the smartest people they could find and kitted out with the absolute best instruments of the day. And the scale of the work they were doing, it's just mind-boggling. Look at this number, over 10,000. That's how many individual measurements of the sun's position were recorded by one astronomer, Ibn Yunus in Cairo. Just think about the dedication that takes, day after day, year after year. This commitment to long-term, super precise data, that in itself was a revolutionary step forward for science.
And all that hard work, all that data, it paid off with some absolutely incredible breakthroughs. You had Abdul Rahman al-Sufi noticing this little smudge or cloud in the sky. Turns out that was the very first recorded observation of the Andromeda galaxy, another galaxy way beyond our own. Then there's al-Battani, whose super careful measurements showed that the sun's orbit wasn't quite as simple as Ptolemy had claimed. And get this, both Ibn al-Haytham and al-Biruni figured out that the Milky Way wasn't some weather event in our atmosphere, which is what Aristotle thought. They correctly proposed that it was actually a massive collection of countless faraway stars.
Now, one of the key pieces of tech for all this was the astrolabe. Okay, so it was originally a Hellenistic invention, but it was scholars in the Islamic world who perfected it, turning it into this incredibly sophisticated analog computer. I mean, they figured out over 1,000 different uses for it. Everything from calculating those prayer times and finding the direction to Mecca to navigating ships. It was truly the scientific Swiss Army knife of its time.
But here's the thing. When you collect so much new, super accurate data, eventually it starts to create a problem. A crisis, really. That ancient Greek model of the universe from Ptolemy, the one that had been the gold standard for 1,000 years, well, it was starting to show some serious cracks. And this sets the stage for what we now call the Moraga Revolution, a quiet but absolutely game-changing moment in the history of science.
So, what was the issue? What was this nagging problem with Ptolemy's model that just didn't sit right with these astronomers?
It all came down to this one really weird mathematical trick called the equant. See, the ancient Greeks were obsessed with perfection. For them, planets had to move in perfect circles at perfectly constant speeds. But Ptolemy couldn't get his model to actually predict where planets would be if he stuck to that rule. So he kind of cheated. He invented this imaginary ghost point in space, the equant. It made the math work, but it broke the rule of uniform motion. It was an ugly fix. It had no physical meaning, and for astronomers who believed the universe should be elegant and make sense, it was a huge problem.
And so they set out to fix it. And they did. A genius at the Moraga Observatory, a guy named Nasir al-Din al-Tusi, came up with this beautiful mathematical tool we now call the Tusi couple. It's this clever little mechanism where a small circle rolls inside a larger one, and it can turn perfect circular motion into perfect back-and-forth straight-line motion. This elegant little device, this was the mathematical key they had been looking for.
So, armed with tools like the Tusi couple, the astronomers at Moraga basically re-engineered the whole cosmic model. On the one hand, you had Ptolemy's old system that needed that weird, non-physical equant, but on the other, you had the new Moraga model. It got rid of the equant completely, it brought back the principle of smooth, uniform circular motion, and, this is the really important part, it was more accurate at predicting where the planets would be. They had finally fixed that 1,000-year-old flaw. And this is where the story gets really wild. So there's this astronomer in Damascus, Ibn al-Shatir, who built on all the work from the Moraga school. He develops these even more refined models for the sun and the moon. And then, silence for about 150 years. Fast forward to the 20th century, when historians are looking back at his manuscripts, and they find something that just blows their minds. The mathematical models he created, the exact geometric constructions he used to solve Ptolemy's problems, are mathematically identical to the ones used by Copernicus in his famous world-changing book. The link is it's undeniable. This was the bridge that led to our modern view of the cosmos.
So, what's the big takeaway here? Well, the legacy of this incredible era isn't just something you'll find in a dusty old history book. It's actually all around us. In fact, it's written across the night sky.
Seriously, next time you look up at the stars, you're actually speaking the language of this legacy. You know those bright stars, Aldebaran, Altair, Betelgeuse. All of those are Arabic names, and the technical terms we astronomers use every single day, words like azimuth, nadir, zenith, they all come directly from Arabic. It's this living, breathing reminder of that scientific heritage. So when you put it all together, you realize this period was anything but passive. It was dynamic, it was innovative, it was absolutely revolutionary. The scholars of the Islamic Golden Age didn't just preserve the flame of Greek science. They took that flame, they fed it, they challenged everything about it, and they forged a new, stronger, more accurate science. And it was that science that laid the mathematical groundwork for the European Renaissance and everything that came after.
And that really leaves us with one final, kind of mind-bending thought. The whole story we just talked about, the connection between the Moraga school and Copernicus, historians only really pieced that together in the middle of the 20th century. It was basically lost history. Which makes you wonder, doesn't it? How many other stories like this,